multiplication and division of fractions. So the examples that you see on the left-hand side, 5 of them, show you what can be possible in terms of solving multiplication and division of various fractions, and you also see some mixed numbers in these examples. By the end of this video, I will solve all of these examples so that you can see what are the steps that I think about when I tackle multiplication and division. But before I do that, here is the agenda that I want to set for this video. I want to talk about multiplication basics, mention the reciprocal for a fraction, talk about division basics, and then finally take the examples that I just showed you and solve them in combination. On the right-hand side of the screen, if you're not familiar, you may like to watch the 3 videos that I created where I talk about primes, proper, improper, mixed fractions, and how to reduce fractions. And those will help you to try to understand the concepts in this video. So let's start with the basics. So multiplication basics. In multiplication, when you have a fraction, and I'll do this by example. For instance, 1/2 multiplied by 3/7. If you want to multiply fractions, the simplest basic related to this multiplication is rather easy to understand. What we do is we take the 2 numerators of the fraction and we basically multiply them together. Now 1 times 3 is 3. And then we take the denominators and we also multiply them together. So 2 times 7 is 14. And we're finished. Now at times our answer might have to be reduced. In this case, it's actually reduced already. So that is the basic concept of multiplication for fractions, where you're just multiplying numerators and then you can multiply the denominators to get your answer. Now, of course, this becomes more complicated, as you will see through the examples that I originally showed you. But that idea of multiplication you have to keep in mind. Now, the next item on our agenda here is this reciprocal. So it's good to know what a reciprocal is. And that reciprocal helps us when we're dealing with division of fractions. For instance, if I take this 3/14 that I just got in my answer above, the reciprocal of 3/14 is nothing else but simply swapping the numerator and the denominator. So my answer would be 14/3. Now, sometimes depending who maybe your teacher is or what you want to do, because this answer is improper, you can always change it back into a mixed number and a proper fraction. 14 divided by 3 is 4, and then the remainder is 2, and our denominator stays the same. So this is a mixed number format, and this right here is improper. So that's the idea of reciprocal. Now let's see a couple of examples, okay, where this reciprocal comes about so that you understand it a little bit better. It is just swapping numerators and denominators. However, as this next example show what happens if, for instance, you have a negative fraction. Well, nothing happens. When you have a negative, and it doesn't matter if it's in the numerator or in the denominator or in front, the reciprocal simply leaves the negative as it is, and all it worries about is the numerator and denominator. So when we now swap, I will get negative 11 over 2. And again, I can change this to a mixed number. 2 into 11 goes 5 times, then I have a half left over. But the negative will just remain. So that's one. Now, another example of a reciprocal is, what if you are given a number which is already in mixed format? Meaning, for instance, what if I have 2 and 1/3 and someone asks you to take the reciprocal? So first you would have to change this to an improper fraction before you start swapping the numerator and denominator. So 3 times 2 is 6 plus the 1, so this is 7 over 3. And now I can take the reciprocal, and that would be 3 over 7. So that's the concept of the reciprocal. Okay, so I'll stop there on the second agenda item. And if I go back here to our agenda, we have multiplication, the reciprocal, and now the basics of division. The basics of division are not too far away from multiplication. If I give you an example, and here I will just illustrate, for instance, and let's take something like this, 3 divided by a half. And let's think about this. I will show you the basics in a second. But what does this actually mean? Well, I have, let's imagine, our famous pizzas. So if I have 3 pizzas, because that's what I have, and I'm sorry, these are not exactly identical circles, they should be, but it represents 3. And now, when we're doing division, what we're asking is, how many times will I have this half go into this 3? Well, visually, this is actually pretty easy, or at least simple, to think about. Well, I can divide these pizzas into a half. So if I do this, so now I've divided all of them into a half. And now what the division asks us is, well, how many halves do you have in these 3? Well, I have 1, 2, 3, 4, 5, and 6. So my answer here is 6. Now, of course, in division, we don't want to be drawing these circles or whatever else you want to represent the leading number by. We would like to have some kind of a basic concept of how can we do this quickly without maybe visualizing it. So the basic division idea is that what we do is, if you have division, we actually change division into multiplication. And when we change it to multiplication, our leading number stays the same. Our division will now change into multiplication. But of course, you may ask, well, can I do that? You can, but only if you take your fraction here, 1 over 2, and take its reciprocal. And we just talked about the reciprocal, and that is 2 over 1. And now notice what happens here. 3 is simply 3 over 1, and it's multiplying by 2 over 1. And from Multiplication basics, well, we know we multiply the numerator, so that's going to be 6. And then we multiply the denominator, which is 1. And of course, 6 over 1 is just 6. And notice that's exactly what we got here in this visual concept. So the reason we take reciprocals is because we're actually asking how many times a fraction goes into something else. And it's much easier to remember the basics with the reciprocal instead of drawing things out like I did above. So another example to illustrate this, okay, for instance, I can take a more complicated fraction. So let's say 2 over 11, and now I want to divide this out by, let's say, something weird like 4 over 5. I don't want to be drawing this to see. It is much easier to use the basics of division, meaning the leading number, or the leading fraction in this case, 2 over 11, just stays the same. Then we take the division and we change it to multiplication, and we have to take the reciprocal, and that is 5 over 4. And now we can go ahead and multiply. So 2 times 5 is 10 all over. 11 times 4 is 44. And now, yes, we may have to reduce this, and I can reduce this because 2 goes into 10 5 times, and 2 goes into 44 22 times, and that will be 5 over 22. Now, I'll come back to this reducing shortly. But the main idea is I just wanted to show you what happens with division. So division is nothing else but multiplication by its reciprocal. So now we know how to do the basics of multiplication. We know what reciprocal is, and we know the basics of division. So let us take these crazy examples, which is going to be the last component. So I'm going to copy these down. And let's try to now solve this. Because of course, multiplication and division can get more complicated. There can be negatives, as you see. You may have mixed numbers, as you see in example 3, and example 4, and example 5. And you can have multiple multiplications and divisions simultaneously, as you see in example 2 onwards. So let's break these down one by one, and I will talk about the steps to follow. So if you are ever thinking about multiplication and division, and you have something a little bit more complicated than just the examples that we showed above, where it's just two fractions, then you can think in these steps. So this is what I do in my mind. It's easier to think of the steps than it is to try to solve the entire thing, because trying to solve the entire thing may intimidate you in a way. So the first thing that I always ask myself when I am just dealing with multiplications and divisions, notice there's no additions or subtractions in any of these. That will be, okay, you're going to be able to watch a different video for that. So first, I ask myself, how many negatives do I have? That's the first item that I do. Okay, and I will then, after finding how many negatives I have, the second thing that I will do is I will want to change all mixed numbers, if there are any, and I will change them to improper fractions. So that would be my second step. Then the next step is, once I do the changing, I basically have now just fractions, no more mixed numbers. Then I will take all my divisions and I will change them to multiplications. And of course, this will mean I would need the reciprocal. So now I have counted my negatives, and I'll show you what we do with those. Number two, I changed mixed numbers to improper fractions, and then I got rid of division, which means all I have is just multiplications of fractions now. Number four, now I reduce. So before doing anything, I actually will start reducing, and I'll show you that through these examples. And then finally, once you reduce, you just evaluate or you solve the whole thing. So let's keep these steps in mind, and you can, as someone who is just starting maybe on these fractions or just learning or relearning them, you can keep these steps, okay, as I'm going through these examples. So let me take the first example, which is this one. So this one is the simplest of all of these. However, so I will, step one, count the number of negatives. Because this is just a multiplication, I can count the negatives, and it doesn't matter where they are. In the numerator, denominators, does not matter. So I have two of them. So here is something that you should know as a student of fractions. So I'm going to write it as a note. And the note is, when you count your negatives, if you have an even number of negatives, your final answer is always going to be positive. And the reason for that is because a negative multiplied by a negative is a positive. Now, if you count your negatives and it turns out that you have an odd number of negatives, then your answer, your final answer, is negative. Now, this is helpful because if you know your answer, then you can just get rid of all the negatives right in the beginning, which will declutter the question. So for instance, for this example, I know there's two negatives, so I know that my answer will be positive. And now I can simply rewrite this without any more negatives. So that's what I have. So that's my step number one, counting negatives. Step two is I want to get rid of mixed numbers. There are none, so great. I'll move over to step number three. Are there any divisions? There are no divisions. Great. Let me move over to step number four, reduce. And here, you may be tempted, because it is just a simple multiplication, you would want to multiply the numerators and then the denominators by the basic rule of multiplication, and then reduce after. I say reduce before, because that allows you to bring down your numerators and denominators to much smaller sizes, and it's easier to evaluate, and then you don't have to reduce at the end. So here is the trick with reduction. The way that reduction works is you have to take one of the numbers on top and try to see if it will reduce with any number at the bottom. And yes, it doesn't have to be a number right below it. It can be a number anywhere in the denominators from the bottom. So for instance, I notice there's 4 and 6, and I can reduce this by 2, meaning that 2 goes into both 4 and 6. How many times? Well, it goes 2 times here and 3 times here. That's my first reduction. Now I ask, can I reduce anything else? Well, the 2 doesn't go into anything at the bottom anymore, so I can't really reduce that. So now I will move over to the 14, and I notice that, hey, there is a 7. Okay, so 14 over 7, well, that can be reduced by 7 itself. So 7 into 7 goes once and goes 2 times. So now notice what happens. Now you have 2 over 1 multiplied by 2 over 3. Much simpler because you've reduced. Now I can't reduce this any further because these are just prime numbers that don't go into each other, meaning 3 doesn't go into 2. Now I can use the basics of multiplication to evaluate. So 2 times 2 is 4. 1 times 3 is 3. The answer was positive. And now if you want to, you can change this to a mixed number. 3 goes into 4 once, and the leftover is 1 over 3. And you are finished with the first example. Let's see the second example. This one is tougher. So I will now take this example and I will walk through exactly the same steps. Step 1, count negatives. So I have 1 negative, 2 negatives, 3 negatives. Great. My answer, so I have 3, which is odd. So my answer will be negative at the end. So this now allows me to drop the negatives entirely. So I have the following left. Step number 2, any mixed numbers? There are none. Step number 3, any divisions? Aha, there is a division. So change division to multiplication. 1 over 2, so this changes to multiplication, and that means that I need the reciprocal, and it's only the reciprocal of the fraction right next to it. The rest remains the same. So that is, if you go back here, so we've done step 1, negatives. There were no mixed numbers. We changed the division. Now we reduce, if we can. So I notice, okay, and you may notice something different. So I notice there's a 2 and there's a 6 on top. 2 goes into 6. So 2 into 2, that goes 3 times. And now again, I notice that, 3 and a 3. So I can reduce that. And that will be 3 goes into 3 once, of course. And notice now what happens. What I have left behind is this reduced set of fractions. Well, now this is much simpler to do. 1 times 1 times 1 is 1, and 1 times 4 times 1 is 4. Now don't forget that your answer is negative. So at the end, you can write this. And the beauty of this is now it's already reduced. It's much easier. And you're also multiplying much smaller numbers here. So those are the steps in action. Let's try an even harder example. I don't know how this one will work out, but we will try it. So here is an example, and I have no negatives in this example. So my answer is right away positive. Now, step number 2, get rid of mixed numbers. In this case, I do have a mixed number. So I will change the mixed number into an improper fraction. 4 times 4 plus 3, that is 19 over 4. So that is my step number 1. There are no other mixed numbers, so I'll move over to the next step, and that is getting rid of divisions. I have 2 of them in this example. Okay, so I will take 19 over 4, division changes, I have to take the reciprocal. Now next, okay, this is a multiplication, that one stays the same. Oh, division, change to multiplication, take the reciprocal. And now all I have remaining is just multiplications. Now let's take the next step, reduce. So I notice there's a 4 here, and 4, actually, I'll try to catch it here, and I notice that 4 goes into 4 once, and it goes into 8 two times. Now, that leaves me in the denominators 1, 1, 11, and 1. 11 is a prime, and unfortunately, on top, I have all primes, and none of them are 11. So I can't reduce this any further. So for this example, now I am stuck because I have to now go ahead and try to multiply these. So it will be a little bit annoying. So let's try to multiply 1 by 1 here. So 19 times 2, so that's 38. So I'm going to do it on the side here. So 38. Then 38 times 2. So we can do that. So 2 times 8 is 16. Carry the 1. 2 times 3 is 6. Plus the 1, that's 76. And now finally, I have to multiply by 3. So that gives me, so 3 times 6 is 18, carry 1. 3 times 7 is 21, plus the 1 is 22. So my answer is 228 all over 11. So now this becomes, of course, it's positive. And if you like, you can change this to a mixed number. Sometimes you have to do that. So what you would have to do is you would have to literally take 228 and divide it by 11. So 11 into 22 goes 2 times. So that's 0. Oh, so 11 into 8 it goes 0 times. Okay, so 0 times 11 is 0. Subtract. So I have a remainder of 8. So this gives me 20. And remainder 8 goes on top, 8 over 11. And that would be your final answer. Okay, let's try the next example. So in the next example, what I have, so it's this one. I'm going to put this down. And let's try this one. Again, there are no negatives. Next, mixed numbers. Now I have two mixed numbers. So let me change them. So first mixed number, so let's change it to improper. So 3 times 1 plus the 2. So 5 over 3 multiplied. 7 times 2, that's 14 plus the 4. So this is what I have here. Now I have two improper fractions. Next step, any divisions? No divisions. Next step, can I reduce? Well, I do notice that I have a 3, and 3 will go into 18. So 3 into 3 once, 3 into 18 6 times. And now actually it looks like nothing else reduces. So now I can evaluate. 5 times 6 is 30, and 1 times 7 is 7. And changing it to mixed numbers, so 7 into 30 goes 4 times, and that is a remainder of 2, and you can double check that for yourself. And now you're done. The final example that I've shown here, which is this one, this will complete, and hopefully now you will see that these steps are rather useful. Okay, step 1. Count the number of negatives. 1, 2, 3. That's it. So that means my answer is, it's an odd number of negatives, so my answer is going to be negative. Step 2, get rid of mixed numbers. So I have one mixed number, and I can get rid of that. Next step, get rid of division. I have that right there. So I'm going to get rid of the division. Changes to multiplication, and we have to take the reciprocal. Next step, reduce. So let's see if we can reduce anything. So let's say this 3, it doesn't go into 4. It does not go into 28. So 3 won't do anything for us. 21, actually 21 and 28 are both divisible by, so 7 is one of them. So I can reduce these by 7. So that will go 3 times, and that will go 4 times. Now that leaves me actually all 3's on top and all 4's at the bottom. So this is as far as I guess I can reduce this, because 3's don't go into 4. And now we evaluate, so we multiply. So 3 times 3 is 9, times 3 is 27. 4 times 4, 16. Now 16 times 4. So if you like, you can just check this for yourself. And now notice that you are done. So I hope you found this video useful. It's all about multiplications and division basics. And also you've seen quite a few relatively complicated examples. All right, thank you for watching.